Hey guys, let's look at a couple of other problems here in section 4.2. These deal with the extreme value theorem. The first problem I want to look at with you is number 23. You'll see that on my Achieve assignment, it's find the maximum and minimum values of the function 7 tangent x minus 14x on the interval 0 to 1. So I automatically know in this problem, I have to take the derivative of this function, find the critical points, locate any critical points that's between 0 and 1, and then evaluate the original function at these endpoints and at the critical point. Whichever is the highest point is the maximum, whichever is the lowest point is the minimum. Pretty straightforward. So I take the derivative of this function, 7 secant squared x minus 14. The critical points occur when that derivative is equal to 0. So that's equal to 0 when 7 secant squared x is equal to 14. I can divide by 7 on both sides, and I get secant squared x is equal to 2. Well, if secant squared x is equal to 2, I think it's easier to solve for this by taking the reciprocal of both sides. Remember, cosine squared is the reciprocal of secant squared. So then I take the reciprocal of the right-hand side as well. 1/2 is the reciprocal of 2. Much easier to solve now. I take the square root of both sides. This tells me that the cosine of x is either the positive or negative square root of 1 over 2, which I know is plus or minus 1 over the root of 2. I rationalize by multiplying by the root of 2 over the root of 2, and I get positive negative the root of 2 over 2. Now, that would actually have several different solutions at values on the unit circle, but the only one that's between 0 and 1 is at the midpoint of quadrant 1. At pi over 4, you know your cosine function is the square root of 2 over 2. You don't need any others because that value is going to be greater than 1. Pi over 4 is a little bit less than 1. So I can say, okay, that's my only critical point relevant to the domain of this problem. So I take my endpoints and my one and only critical point within those endpoints of pi over 4, and I evaluate them in the original function. And it was pretty straightforward in the evaluation. You know that the tangent of 0 is 0. 14 times 0 is 0. So when you plug in a 0, you get a 0. When you plug in pi over 4, the tangent of pi over 4, it's just saying what's the ratio of sine to cosine at that point. Of course, it's a 1. So you'd say 7 tangent pi over 4 is 7 times 1, and then you get minus 14 times pi over 4. I simplified that down to 7 minus 7 pi over 2. Now, I went ahead and simplified that to a decimal answer of negative 3.996. Achieve wants exact answers, but sometimes it helps to get the decimal just so you can realize whether that's the low value in this case or not. I needed to because whenever I plugged in the 1, it's going to give me an irrational number. The tangent of 1 is not a number that we should be familiar with. So I just said 7 tangent 1 minus 14, and you can even see here on the calculator where I did that, it's up at the very top, 7 tangent 1 minus 14. It was the negative 3.098 answer there. So now I know that this value is not my minimum because it's not as low as that one. So the minimum in this problem occurred at pi over 4. The Achieve system only wants the y value of the minimum. You'll see it up there. It says y minimum and y maximum. Well, the maximum value is 0. I'll go ahead and input these values in, the 0 and then the 7 minus 7 pi over 2 for the minimum. So I'll say 7 minus, and then I have the fraction, 7 pi all over 2. I'll check that answer, and it says correct. The next one I also want to look at with you and try to make sure you're comfortable with it. It's having us look at a function where we have the natural log of x divided by x, and it's wanting us to find the maximum or minimum value using the closed interval test between 1 and 4. So I know I need to find the critical points. Critical points are where the derivative is equal to 0. I take my derivative, low d high minus high d low. Derivative of x was just 1, so I didn't bother to put it, all over the denominator squared. So now notice in that numerator, it's going to simplify. X times 1 over x, simply 1. I have 1 minus the natural log of x over x squared. Set that equal to 0. The only way a fraction can equal 0 is if the numerator of that fraction is equal to 0. So that gives me the natural log of x is equal to 1. Once I have the natural log of x is equal to 1, then I can exponentiate each side of that equation. E to the natural log of x should equal e to the 1. Well, e and natural log eliminate one another, and you just have x on the right-hand side. You have your e to the first, or just e on the left. So now I can say my critical point e, that's certainly within the 1 to 4, because I know e is 2.71828. So I evaluate at 1, at e, and at 4. And again, this is easy to evaluate. The first one, the natural log of 1, by definition is 0. So you have 0 over 1, 0. The natural log of e, by definition, is 1. So we're going to get a 1 over e. And I went ahead and went to my calculator to get the decimal approximation for that because I didn't know exactly what 1 over e was equal to. Rounds to 0.368. And then you'll see in the last one, of course, you had to plug in the natural log of 4 over 4. I didn't know what that was. I went to my calculator and saw that it was 0.347. Now, Achieve is wanting the exact answers for the maximum and minimum values, so I can clearly see that my maximum is 1 over e and that my minimum is 0. So I'll go up here and say minimum value is 0. And then for my next one here, I should just be able to say 1 over e. Should work just fine. Let's check that. And it's saying correct. Okay, hopefully this helps you out with these two problems in this section. Let me know if you have any other questions. Be glad to help.